Hi, today I'm going to go over differentiating basic functions using the power rule. So the power rule is great for differentiating functions that look something a little bit like this. So we could have like 3x cubed minus 4x squared plus 5x and then minus 9, some constant. So the power rule is when you're differentiating a function where x is raised to some constant exponent. So here we have x to the constant exponent 3, and then minus 4x squared. X is raised to some constant exponent, and the power rule states that if we have, let's say we have x to the n, and we want to differentiate that, we would get nx to the n minus 1. That is the power rule. So let's differentiate this function for fun. So we get f prime at x, so we'd get 3 times, and then we have x cubed. When we differentiate that, we get n, which is 3. So 3 times x, n minus 1, and 3 minus 1 is 2. So we get 3 times 3x squared. That's it. And then 4 minus 4, and then 2x plus 5. And then the derivative of a constant is just 0. So we can ignore that 9. And then we get 3 times 3 is 9x squared minus 4 times 2 is 8x plus 5. And that's our derivative. Now let's do something a little bit more fun. Let's say we have f at x is equal to 5x to the 10 minus 3x plus square root of x. So what I'm going to do before I differentiate this is I'm going to rewrite this a little bit differently. I'm going to rewrite the square root of x into something a little bit more easier to understand for the power rule. I'm going to rewrite it as x to the 1/2. Because that's what the square root essentially is. It's just anything raised to 1/2. So f prime at x will just be 5 times, and then we have 10x to the 9 minus 3. And then plus, we bring the 1/2 out. And then we have x. So 1/2 minus 1 is negative 1/2. I'm going to make it look a little bit more like an exponent. And I can rewrite this using exponent. So 5 times 10 is 50, x to the 9 minus 3. And then I can rewrite this a little bit differently. So with negative exponents, I can rewrite it as 1 over that exponent. So I could do 1 over x to the 1/2. So I'm going to do that. X to the 1/2 is just, we can rewrite it as root x. And that is our answer. Let's do one more fun one, just for fun, just for old time's sake. So 1000x to the 1000, big numbers, minus 5x to the negative 3. Very contrasting exponents. So let's differentiate this. We have the constant 1000 multiplied by 1000x. 1000 minus 1 is 999 minus 5, and then we bring down the negative 3, x, and then negative 3 minus 1 is negative 4. This becomes 1,000,000, commas, x to the 999, minus 5 times negative 3 is a plus 15, x to the negative 4. Now, we could rewrite this as 15 over x to the 4, but a general rule is the form of the original question was x to the negative 3. So we can leave it as x to the negative 4. If I wrote it as minus 5 over x cubed, then I would have to rewrite it in the other form. That concludes this video. I hope you found this helpful. Thank you so much for watching, and have a good day.